Section 1.4, Division with whole numbers. Here we're going to be learning how to divide whole numbers, know how to divide with zero, and divide using long division. Okay, here we got division with whole numbers. The procedure, when you have a dividend, that's going to be your big number, I guess you could kind of say, and you divide it by the divisor, okay, that's going to equal another number. So notice here you got 24 divided by 6, that's going to equal 4. And when you look back at multiplication, you can notice that this 4 and 6, you can come here and go 4 times 6, and that's going to equal your 24 here. Well, same thing with 35. You got 35 divided by 7, okay, it divides evenly, and you're going to get a 5. Okay, we'll notice here that 5 times 7 is equal to 35. So we'll continue on to the next part so you can kind of see the relationship a little bit better. They continue on with all numbers. Okay, 24 divided by 6. Well, when we divide 24 by 6, we get 4. Okay, well, notice that also whenever we take 4 and multiply it by 6, we can get back to the original 24. So since this is fast subtraction, going back the other direction, doing the fast addition, we can get back to our original 24. Well, 26 divided by 2, well, that's going to equal 13. And notice here that 2 times 13 is also going to equal 26. So we can kind of, I guess you'd say, reverse the process. Okay, this 72 over 8, this is also known as it's not just a fraction. We consider that a division symbol as well. So 72 divided by 8 is going to equal 9. And then we know that 9 times 8 is also equal to 72. Well, here's another one here. Is 35 divided by 1. Well, how many times will 1 go into 35? Well, 35 divided by 1 is going to be 35. And 1 times 35 is going to be 35. Okay, because this is an identity. And then here's a good way to think about this. 17 divided by 17. Well, how many times will 17 go into 17? Well, that equals 1 time. And you could also say it like this, is 1 times 17, that is still 17. Okay? So that's kind of the relationship that you're going to see. Now let's hear division by 1. Any number divided by 1 is itself. Okay? This is division by 1. And then division by itself. Any non-zero number divided by itself equals 1. Okay, non-zero. Okay, so remember, it can't be 0. You'll find out about that more later. So it's 3 by 3. Well, that equals 1 because how many times will 3 go into 3? Just 1 time. Okay, very important. Okay, kind of put some stars around this. Case 1. Any non-zero whole number can be divided into 0 and the quotient is 0. Okay, example. 0 divided by 7 is okay. Okay? How many times will 7 go into 0? 0 times. Okay? Just think of it that way. I don't want to get too conceptual. This may be something that you may just have to come and go, okay, I can remember this. When this is the numerator, when 0 is the numerator, it's always going to equal 0. Okay? Case 2. If any known number, including 0, is divided by 0, the quotient is undefined. So basically, 13 will go into 0, or sorry, 0 will go into 13. How many times? Well, that doesn't make sense as much, okay? And if I'm kind of losing you there, I would suggest just realize, hey, just trust me on this right now, because even if you see this, 0 divided by 0, okay, this is still undefined, okay? Just kind of a rule. You cannot divide by 0. It's just a basic rule of math. As you progress further and further along in math, you're going to see it a lot more and you're going to understand it and conceptualize it a little bit better. But until then, it's just sort of like one of those things of just kind of just trust your math teacher. Okay, so let's look here. 0 divided by 23 is 0. That is okay. Okay, or 0 divided by 23. See? 23 divided by 0. That's all okay. So these are okay. But notice, 14 divided by 0, that's undefined. Okay, not 0. This is what it says. This is how you have to answer me. If I ask this in class, when I say 14 divided by 0, what is it? Undefined. Okay, or that one. Okay, or that one. Remember, 0 cannot be the divisor. Okay, that's going to be one of those, like, just say it in your head. 0 can't be the divisor. 0 can't be the divisor. Okay? Okay, long division. Division problems can be checked using multiplication. To do so, multiply the divisor, okay, by the quotient and add the remainder. This will give you the dividend. This is shown in the following examples. Okay, kind of just do a couple examples here so you kind of know what we're talking about. Okay, 683 divided by 7. Okay, we're going to come in here and we're going to do this long division style. And of course, knowing your multiples is going to just help out immensely on this. So I would suggest practicing your multiplication tables. There's multiplication tables in your Canvas shell. Just practice those as much as possible until they become muscle memory. You're going to forget them every once in a while. That's understandable, but practice makes perfect. So how many times will 7 go into 68? Well, it's not going to go in evenly, but the closest I can get to this is going to be a 9. And what I'm going to do is I'm going to place this 9 right above the tens place right there. Okay, now here's what we're going to do. We're going to do 9 times 7. Well, that's going to be 63. Okay, then I'll subtract this. 68 minus 63 is going to give me a 5. Now I have to bring down this 3. Okay, how many times will 7 go into 53? Well, it'll go in 7 times because 7 times 7 is 49. So you see the process. How many times will this go into that? As close as possible is 9. Then I do the 9 times 7, get the 63, subtract it out, bring down the next number. And we're just going to continue this process until we get to the very end. Notice I don't have any other numbers to bring down. So now I can do my subtraction. I've got 13 here. This goes to a 4. So this right here is going to be a 4. Okay? So here I would have a remainder of 4. Well, we can check this. Okay? We can do 7. Okay, times 97. Okay, well that's going to be a 14 right here. Sorry, 49, I'm sorry. 7 times 7 is 49. And then I can come here and go, well, what's 9? Okay, 9 times 7 is 63. So I come here and get 63, but notice I've got this 4 on top here, so I need to go ahead and add that. So I've got 63, okay, 64, 65, 66, 67. Okay, 67. Well, notice it says I also have to add this remainder here. So I add 4 to this. So then I get 13 plus 1. I get an 8. And then I get the 6. And then notice the 683 is exactly what I was aiming for right there. So you can go back and check it with the multiplication. Okay, let's continue on here. Find the quotient and the remainder of 696 divided by 30. Okay. Here we've got 30 going into 696. Okay, well, how many times will 30 go into 60? Because notice I've got 2 digits here, so I'm going to try to get as close as I can to these first 2 right here. So 30, I'm not even going to worry about the 6 yet. 30 will go into 60 2 times. Okay, well 2 times 30 is going to give me 60. Come in here, I'm going to subtract all this off, and I'm going to get a 9. Now I'm going to bring down this 6. So 30 will go into 90. Well, it'll go in 3 times. Okay, 3 times 30 is going to give me 90. Bring this all down and I get a remainder of 6. And you just put those over here as a remainder of 6. Well, now I can double check all this. Notice I can come in here and go, okay, well, how about 23 times 30? Okay, well, this first part, that's going to be easy. I've got a 0 and a 0. Then don't forget, I'm going to move over to the tens place, so I need to go and put a 0 here. Well, 3 times 3 is 9. And then 3 times 2 is 6. Okay, add all this up and I'm going to get 690. Now I need to add this 6 here. Come in here, add the 6. And notice I get the 696, the original number that I was going for. Okay, let's continue on here. Because I had just plenty of examples. The more examples, the better. Here we got 9,325 divided by 45. So let's take a look at this one. How many times will 45 here go into 93? And some of these you're going to play with. Like I said, 45 is kind of a hard number to think about. So you might have to come here and try to do some multiplication. What's 45 times 2? What's 45 times 3? On this one I can tell you that 45 will go into 93 2 times. And when you come back in here and multiply this out, you get 2 times 45 is going to be 90. Then I'm going to subtract that, okay, and I'm going to be left with a 3. Bring down the 2, okay, and notice how many times will 45 go into 32? It won't go in any times. So I can come in here and just put a 0, multiply that back out, and of course I'm going to get a 0, and then I can bring everything down, okay? So then I get 32, bring down the 5, okay? And then this one you're going to have to play with for a little bit. Like you're going to say, okay, well, how many times will 45 go into 325? Because now we do have to worry about all three numbers. I can't just come in here and just start worrying about this first part. I have to do all three numbers. Like for example, if I decide to go ahead and try 8, okay, well I can do 8 times 45, and notice that's going to give me 360. Okay, well 360 is too large. I can't put that down here. It cannot be larger than this 325. So if I go down by 1, I can go 7 times 45. And what does that give me? Well, that ends up giving me 315, which is just beneath with this one right here, which is just fine with me. So I can come in here and put a 7 here, and then go 7 times 45 is going to give me 315 with a remainder of 10. Okay, and of course you can go back in here and check this out and make sure it works. I can come in here and go, okay, well, what's 207 times 45? We'll come in here, 5 times 7 is going to be 35. Put a 3 here. Okay, 5 times 0 is 0, plus 3 is going to give me a 3, and then I got 5 times 2 is 10. Don't forget to put your 0 because we're moving over to the tens place. Okay, 4 times 7 is 28. Okay, come over here. Notice I'm going to mark out this 3 and put the 2 above it now. 4 times 0 is 0, plus 2 is 2, and then 4 times 2 is just going to give me an 8. Okay, I'm going to add all these up together, and I get 5, okay, 11, 3, and then 9. And then notice I'll take this 10 and put it down here. And then I get 5, 2, 3, 9. And then notice I get 9,325, which is back to my original number. So this is an easy way to go ahead and check yourself. If you're worried about whether you did it right, you can always go back and double check. And if you did make a mistake somewhere, you'll know. Okay, good little thing I'm leaving here on, it's also in your PDF form, is the wrong solutions here. Writing 0 in the quotient gives the correct quotient of 408, which is considerably different from 48. Okay, notice right here, okay, we had to put the 0, okay? Just kind of showing this how they divided this one out. Notice if you have somewhere that there is a 0 that happens, like right here, you have to put the 0 in there, okay? Because notice the 17 won't go into the 13 here, so they had to put the 0. So it's a good little kind of a rule of thumb to kind of remember. Okay, let's go to the next part here. Okay, show that 19 and 43 are factors or divisors of 817, okay? In order to show that 19 and 43 are factors of 817, we divide both 817 by 19 and 817 by 43, and that will give a remainder of 0 if indeed these numbers are factors of 817. We only need to try one of them to find out if the remainder is 0. Okay, well, let's come over here. Watch this. Okay, so we're going to come in here and we're going to start trying out we're going to go ahead and divide this out first. Okay, we're going to see that 19 will go into 81. It'll go in there 4 times, okay? Which, when you get better at estimation, you can kind of do this, or you can do the guess and check. Doesn't really matter, okay? So 4 times 19 is going to give me 76. Okay, I'm going to subtract that off. Whenever I subtract that off, I'm going to be left with a 5. I'll bring down this 7 here, and then 19 will go into 57. It'll go in 3 times, and 3 times 19 is 57. Okay, and notice whenever I multiply this, when I subtract this, I get 0. So yes, that does show me that 19 is a factor of 817. Well, let's come over here and we can do the check. 43 times 19. Well, I've got 9 times 3, which could be 9, 18, 27. Okay, here's going to be 36 plus 2. That's going to give me a 38. We're going over the tens part, so let's go put a 0 here. And then I've got a 3 and I've got a 4. Okay, so let's come over here. I got 7, and then here I've got an 11, and then here I've got the 817. So I get back to my original number. So that's what it's saying. Thus, 19 and 43 are indeed factors, okay, of 817. And factors means I can just take these numbers, multiply them together, and get 817. Or I could have also divided 817 by 43, and I would actually got 19. Okay, so that's how you can find out if something is a divisor or a factor of a number. Is remember, you got to get back to this remainder of 0. There can't be any sort of remainder left.